Okay, this last presentation is it's going to cover the actually the installation process taken in both demo site buildings in Coventry University, John Lang and Richard Crossman, the buildings that we've been looking at. And also I will explain a bit of the user acceptance assessment that we did as part of the project, and also some stakeholder engagement, which we consider that this is something very important to take into account in any low carbon retrofit in buildings, especially buildings that had users before any refurbishment takes into place. We need to take into account the end users' behavior and thermal comfort before any retrofitting activities take place. So looking at the building stock of Coventry University, this is the center of the city, and you can see that Coventry University has a large building stock. But most of those buildings date from the 30s to the 70s, before any energy efficiency component in the UK came into force. That was in 1985. So this is the reason why the energy performance of most of those buildings is so poor. And this is why the State's Department is trying to upgrade those buildings in Coventry University. So this project was an opportunity to contribute to that. In the first place, we considered 6 buildings: Alan Berry, Ellen Terry, George Eliot, etc., because they were more or less built in the 60s, 70s, and they had a mixture of uses. As you can see here, the different photos of the buildings, and the year of construction and characteristics. Alan Berry in 1963, all of them, except Ellen Terry, which was built in 1931, almost all of them, the rest, more or less around the 60s, 70s. With 30-40 glaze proportion and brick facade, most of them. In the end, we decided to select Sir John Lang building and Richard Crossman building because of the floor area, the energy use, because John Lang offered us the opportunity to use it as a living lab, because it's about of its end of life, this building, and it's supposed to be knocked down at some point. So this offered us the opportunity to test some technologies in isolation, innovative technologies, and use it as a living lab. Whereas Richard Crossman, because the university already had plans to upgrade this building, it married up quite nicely with the objectives of the project. So as Abdullahi commented before, he introduced the idea of the project of trying to produce a tool which allows us to get the best retrofit mix, customized to the needs to each building, as a decision support tool. And in the particular case of John Lang building, for this retrofit mix, we decided to undertake a building performance assessment of the fabric. We went to the archives of the State's Department to see what was the wall composition. We undertook some structural survey, asbestos survey, also indoor environmental quality measurements, etc. And as you can imagine, when we undertook the asbestos survey, we found asbestos in the building, around the windows, asbestos packers. So this was a setback in the sense that we wanted to change the windows, because obviously if you have single glazed windows and you start improving all the envelope of the building, if you don't change the windows, you are doing almost nothing. So, and this was a setback in the sense that because it was a living lab, if we decided to change the windows, it would be quite a hassle in terms of money, control environment, also disruption, because the building is in use. So we have students, we have all the lecturers. So in the end, we decided not to undertake this, and just the technologies that we've been seeing before, and then just try to analyze those technologies in isolation. What's the improvement of those technologies? And also as a result, and also the asbestos survey, with the structural survey, we decided that the approach in Yonlang would be more like an addition of layers rather than changing elements of the building, which is quite a nice approach, because there are lots of listed buildings who actually we cannot change elements, and we have to follow the same approach of just adding layers because they are listed and we cannot alter the composition. This has been covered already, the technology selection in Yonlang. Different are retrofit mix of envelope elements, improvement of the services, and also renewables, in this case the solar PV panels. This is where the technologies were placed. And when doing the technology selection, the approach of the PCM, we selected this in the end because, as we said before, some of the offices or some of the rooms suffer from a lot of overheat. So it was a way of counteract that issue. And because of that, we have high internal gains from equipment, students, etc. And this space was supposed to offer potential to be ventilated, but in the end, as we mentioned before, for some issues of with the protection, we couldn't ventilate that space. And also we installed those PCM tubes in some rooms, which offer us the possibility to compare some results between the different offices. Regarding the aerogel mortar, the EPS and vacuum insulated panels, those are different options for exterior insulation materials, which is quite nice, because when we it's a very good option for upgrading the insulation of a building, this external insulation. But here we could try different options, not just the typical EPS, the polystyrene. We could also try aerogel mortar and vacuum insulated panels, so we could test the difference between those systems. And these were the technology selected for Richard Crossman, also a retrofit mix, where we are mixing the improvement of the envelope elements, but also the building services, the lighting, and also adding the renewables. And moving forward to the installation process, here you can see some photos of the installation process. This is actually you can see there the facade with the insulating material, and also the finishing, which is the solar PV panel. But you can see also there on the right hand side, you can see the installation process with the vacuum insulated panels, and also how they install the, we have this here, thank you. So this is the vacuum, these are the vacuum insulated panels, and then how they were placing the solar PV panels. And as we mentioned before, vacuum insulated panels have a very good performance in terms that they can have an equivalent performance of 10 times higher of a material of the same thickness, which is quite good. But for achieving that, it doesn't have to lose the vacuum. This is very, very important. And particularly in this installation, you can see this panel here, and it has lost some of the vacuum. So that's why we had to repeat the installation in other panels as well. Because in the end, in the project, with these technologies like vacuum insulating panels, aerogel mortar, they are state-of-the-art technologies, and there are lots of market barriers from these technologies to actually get to the consumer and to the installers, because they don't know how to install them. They don't know how to handle those products. This is the aerogel mortar. This material was produced and tested specifically for this project, for the RESSEEPE project. It's a material that doesn't exist. You can see aerogel in plaster boards, but not in mortar, because it's quite difficult to obtain a good performance with a mortar. And well, you've been passing through the aerogel mortar, but then it's mixed with water, and it has this aspect. And then it has to be applied in 2 layers of 2 centimeters each. And these were the contractors that had to do a specific training for this particular product. And also, this product is supposed to be done by spray system, but because it was just a living lab and just a small sample, we had to do it by hand, which meant that the water mortar ratio had to be altered in this case. This is the image of the PCM tubes without these things. And in this case, the experience was successful in the sense that we approached different contractors, and because they weren't familiar with the product, they weren't very happy to install it. But we found a company who said, okay, let's try it. And after installing this product, they felt like, it's been very straightforward, so we don't mind doing more. If you want to install more PCM products, just call us, because we find out that it's very straightforward. So in the end, sometimes it's not that the product is difficult to install, it's just that they don't know how to install it. And the first response is just, no, I don't want to try something new. But then when they try, if they find that it's straightforward and easy, they want to continue and to do it again. In Richard Crossman, we installed LED lighting, high efficiency glazing, the improvement of the roof, and these are the PV panels that we couldn't see before. This is the roof with the solar PV panels in Richard Crossman. In terms of challenges and lessons learned, mainly we found some barriers, administrative barriers, logically, because it's an international project with lots of partners, so it's complicated to handle. But especially these barriers between the market and the end user or the contractor, because we found that there was a challenge in preparing method statements to install this state-of-the-art technologies. The industrial partners, they know very, very well about their product, but now how this product interacts with the building and with other products, or how to install this product. So this was a bit of a challenge, but I think we successfully overcome it. And obviously others, in terms of matching the aesthetic of the 16 design with the technology with the 16 design, and something that happens in a lot of existing buildings. If you still have people using the building, obviously it's going to cause a lot of disruption. One of the buildings was also a hospital, the one in Barcelona, and obviously that was causing also a lot of disruption. And to finish the presentation, I'm going to talk about the user acceptance assessment that we followed in the project. And this was to ensure that the RESSEEPE solutions met the real needs of the users. And we covered several issues about indoor environmental conditions such as thermal comfort, visual comfort, acoustic comfort, etc. This is like a matrix of the process that we follow. So first the user, I don't know where I am, here. The user perception before retrofitting through a user satisfaction survey and also the analysis of the indoor environmental conditions, then the user acceptance of the selection process through some stakeholder engagement events, then the acceptance and perception of the installation process and after retrofitting. So we wanted to assess the level of disruption of the installation process and also the indoor environmental conditions after the retrofitting. And we decided to do this performance data analysis before and after, so we could check before and after. We had the user satisfaction surveys before and after, and also the assessment of the indoor environmental conditions to check if the assessment of the users matched the real data that we were gathering. In John Lang, we decided to do the survey in this space that we've been before, the architecture studio and the offices. This was the model of survey that we distributed. About temperature and air quality, noise and lighting, personal control, etc. And these are some of the preliminary results. We are still analyzing the data. But for example, in the architectural studio, the overall conditions in winter before adding the PCM tubes and after adding the tubes, we can see an improvement, a slight improvement in the overall conditions in winter according to the students. So that might be that. Now we need to check that with the data that we've been gathering to see, to match both results. And in summer, in the same space, we can also see a bit of improvement. And this is in Richard Crossman. They identify the users that the key indoor environmental problems before refurbishment were mainly thermal comfort, visual comfort, and lighting issues. And after refurbishment, they identified that the major improvements were, apart from aesthetics, obviously, and toilets, lighting, visual comfort, and thermal comfort as well. So some improvement has been reached. And this is the last slide. We also, as I said before, we decided to do some stakeholder engagement meetings with the State Department, with end users, with facilities manager, to explain what the project was about and to engage them in the project. And we had very successful feedback from them. We did these stakeholder engagement meetings at different points of the project. And I think that's all. Thank you very much.